sorting algorithm is comparison-based algorithm, in which each pair of adjacent element is compared in element order. This algorithm is not suitable for large datasets.
Bubble sort is a sorting that works by repeatedly stepping through lists that need to be sorted, comparing each pair of adjacent items and swapping them if they are in the wrong order.
This passing
procedure is repeated until no stops are required. Bubble sort has a worst case and average complexity of O and 2, where n is the number of items sorted.
Unlike the other sorting algorithms, bubble sort detects whether the sorted list is efficiently built into the algorithm.
Let's try some example of bubble sort. So we have here some unsorted array, and we are going to sort it as a bubble sort would be. Now we look at first and second number. I think first and second. We see that 60 is bigger than 30. That means they are in correct order. So at the algorithms say, we swap them. Yeah. And now we compare the second and third number. We see that 60 is bigger than 10, so we swap them again. So we move on to the next two numbers, 60 and 70. As you can see, 60 is smaller than 70, so that means that they are in correct order. So now we just move on to the two numbers. Now we compare 70 and 50. 70 is bigger than 50, so we swap them. Like that. Next, we compare 70 and 40. 70 is bigger than 40, so we swap them. Yeah. Next, 70 and 20. 70 is bigger than 20, so we swap them. Yeah. So as you can see, 70 is a kind of bubble to the end. That's why this algorithm is called bubble sort. Big elements bubble toward the end, while the smaller ones are bubbling towards the beginning. So we just finished the first round of our algorithm. So we know that the last number is the biggest, and there is no need to compare. Because this number is in correct place, we just continue bubbling the biggest number to the end until we have no numbers to swap. So let's start from the beginning. Let's compare 30 and 10. 30 is bigger than 10, so we swap them.
Now we compare 30 and 60. They are in correct order, right? So we will do now is we will leave them alone and move on to the next. Moving on to 60 and 50. We swap them because 60 is bigger. Now moving on to 60 and 40. And what we're gonna do, we swap them. And same will happen with 60 and 20. 60 is bigger, so we swap them. Now we have the second biggest number, incorrect spot. So we just finished the second round. Now let's start from the beginning. We compare 10 and 30. Obviously, they are in the right place. So we just leave them and move on to the next number. Next would be 50 and 40. 50 is bigger, so we swap 50 to 40. Next one is 50 and 20. 50 is bigger than 20, so we swap them.
Oh.
So we have finished the third round. Let's move on to the next round. Let's start from the beginning. 10 and 30 is in the right place, so we leave them. Also 30 and 40. Next, we compare 40 and 20. 40 is bigger than 20, so we swap them. So we found the fourth biggest number, so let's start again from the beginning. 10 and 30 is in the right place. Now we compare 30 and 20. 30 is bigger than 20, so we swap them. This is the sorted array, and this is how bubble sort works.